Hello everybody, welcome to this course. And in this one, we're going to take a look at the modularity for environment design for video games. Of course, you might think that modularity is a new technique, but it's not. It dates way back to previous generations, and even Sega and Nintendo days. Even there, it was a form of modularity present. They had some sprites and they tiled them over and over again to create an environment. But it evolved through the time, and now we're going to explore what modularity is and how to use it. Of course, modularity is a technique. It has benefits and weaknesses as well. And it's on you, the environment designer, to decide if you want the environment to be modular or not. We're going to see how it does, how it works, and then decide on what type of technique we are going to use for creating modularity, or even leaving modularity to be off and going for a total unique environment. And based on my experience as a teacher, I found out that assigning projects and doing a project-based approach in learning is a lot better. And for that, we're going to go to Victorian era and create some Victorian buildings, because not only they have some challenges, but they are beautiful to look at. They are challenging but beautiful to create. And in the end, you are going to take a lot of lessons from them. So what is modularity? Well, first we need to see what modular design is. Modular design is basically dividing a system into many smaller chunks, and we call those chunks as modules. And these modules can be independently created, modified, and even used on different modules, on different systems. If we create them carefully, we can use them, swap them on another system as well. And the greatest example of this system is the Lego. And we are all familiar with the Lego and how they work. These Lego bricks are all created in a way that we can create different things by connecting these Lego pieces together, and things that the original creator of these Legos have never imagined of. And the things that we do using these Legos goes beyond the imagination of the original creator. The Lego company has made these, and we have total freedom to use these to create new systems. And we can create things as far as our imagination can go with. Of course, there are some rules to creating these Lego kits to make them snap together and tile perfectly to create a system that works. And we're going to learn them later on, but it's good to know that you can create basically anything you want with these kits. Of course, there's a bit of difference for the game design, for environment design, and it is the fact that for every purpose that you want to create a kit to support that idea. And let's go to the reference and just take a look at these. And the first one is this one. In order to make this one modular, we need to create a kit for it. And the kit for this one depends on how far you want to go for modularity. For example, if you're going to create one piece and tile it together in the game, or create different pieces and prefab them and use them in the engine. And it depends on you on how far in modularity you want to go for your game. For example, you can go and create this one as a single piece and tile it all over in your game. And that's not really no problem. You can take this one as a single piece and take it as only a single piece and tile it to create this railing system. But you can go further and do something else. For example, you can go and do something like this. For example, instead of making this one a single kit, you can go ahead and start to divide it into a smaller chunks. For example, this top piece as a single piece, this pillars as a single piece that tiles, and you can place it as you want, and this one as a single piece as well. And it really depends on what type of environment and how much customization you want, because if you go for something like this, you have the kit, you have this single one, and if you duplicate it, sometimes you're going to see some repetition, and the repetition is something that you want to avoid when going to create modularity. But this one is a lot faster to create, because you create one and it's done. you bring it into engine and start to level design with it. But in this one, you need to create them the way that you create this one, obviously. But the difference is that you bring these as individual pieces into engine and start to tile them separately. For example, in order to create this one, you need to bring this, and then from content browser, bring this top piece, and then bring the pillars in the middle. For example, you need to bring in 10 pillars and start to hand place them together to create something that is unique. But this one is going to take a lot of time. Of course, that really depends on your project, and we're going to discover these concepts as well. And there are a lot of times when, for example, you're going to create a strategy game. And for a strategy games, you really do not need to go so far away. For example, when you're looking at the environment in such a high distance, you really do not want to have a lot of modularity. And the modularity in such a place is just taking a whole block and duplicate it and bring it over to create something like this. Because in a strategy game that you're looking at the environment from so far away, you really do not need to have a lot of customizability for your modularity. For example, going in such a level and start to swap windows to create a unique piece. You really do not want to do something like this if the game is something like a strategy game. But for a game like a first-person shooter, when you're going to see the environment from so close up, from the person's eyes level of view, you need to have more customizability for your modularity. So that really depends on how far in modularity you want to go, and that is based on the game that you want to create. And back to what we were talking about, for creating modularity for games, you need to first have a lot of planning. And this planning makes sure that you really do not fail in the middle of the project. For example, I see that I'm going to create a couple of kinds of buildings. One like this, which has a lot of ornament work and a lot of concrete work and things like that. And one like this one. And to support both of them, I need to create a couple of kits. One for this building and one for this building. And when we made sure that both of them work correct, we can create a lot of variations from the same kit. Of course, the kits are not only going to be building kits. For example, we can create pipe kits as well, which I believe we might create in this course. And the sky is the limit on how far you can create kits. But the most important factor is that the kits should be functional and be beautiful to look at. And you should avoid repetition as much as you can. For example, bringing a lot of decals, bringing some foliage to cover some seams, and the techniques that we're going to learn in the way. And the planning stage is one of the most important ones, because without the proper planning, you're going to fail. And you need to plan a lot of things. For example, how to hide the repetition, because in modularity, there might be a lot of repetition. For example, creating such a building, you need to create some kits, and you see how repetitive these windows get when they tile together. And it makes a boring effect, and you need to do something to avoid such an effect. You might introduce unique pieces, you might introduce variant pieces, you might bring in decals, some foliages and things like that to cover the repetition. And this repetition is one of the weaknesses of the modularity. But the good thing is that when you're going to create a building, for example this one, as a modular kit, you really, instead of going and modeling the building once and bringing into engine, you can go and model the windows. And instead of modeling them all together, you can model just one building and tile it over to create this piece. And without modularity, you model this one and the texture resolution isn't going to be too good, because a building that is so great needs a lot of texture resolution. And you might bring in some 4K textures to really maintain the texture quality. But in modularity, you can bring in a smaller textures because they can be tiled together. You can bring in some tiling textures and tile them across without any problem. So this one brings us to the strengths and weaknesses. the first weakness of this method is that it needs a lot of pre-planning. You need to really sit down and calculate how the kits are going to snap together, how they're going to get tiled, and how to match them with other kits, how to swap kits together, how to cover the repetitions and things like that. It takes a lot of planning, a lot of pre-planning. And the good thing is that when you do the pre-planning, it's really a matter of iteration, because you have created the planning and you have a strong ground to continue, and you continue to iterate on top of each other to create the environment that you want. And the next strength is that you can create a world using only limited resources. For example, you can go and create a building kit, and this building kit, you can have some doors, some windows, some walls, some railings, some rooftops, and you can create a whole world using this one. You can bring in a lot of buildings and iterate on top of each other to create so many building types. Of course, the building types is limited to how many kits you have created. But the good news is that you can create literally a whole game using some limited resources. And the bad news is that it looks repetitive, because we are only using some limited kits. The amount of uniqueness and authenticity of the world is going to be questioned, because you're using some limited kits to create whole buildings. Of course, you can go ahead and create different kits and mix and match them together to create authenticity and uniqueness, but right out of the box, they might look repetitive, and you need to do some things to cure that. And to cure this repetitiveness of the modularity, you can bring in different kits. Of course, it takes more time, but it's worth the time that you put in there, because having more kits, you'll be able to create more robust worlds. And again, let's go back to these. And in here, you see we have 3 different kits, each of them belonging to another type of the city. If you create only one kit, say for example this one, and create a whole city using this kit, you're going to have a lot of repetition. But if you introduce more kits, for example a kit like this one and a kit like this one, and start to address a city, you're going to have less repetition. And you can even mix and match kits together. For example, when you're going to create a building that uses the red bricks just like this one, bring in some elements from these. For example, windows, bring in some doors, or bring in some elements from these. You can mix and match kits together to create authenticity into the world. And the next one is creating kit variations. And of course, we're going to talk about kits, but it's good to know that, for example, in this building, there's a lot of repetition. You see this window being repeated over and over again. But in here, we have a different piece that is totally different to other pieces. And this is good to create a little bit of variation in the building. Or even you can bring in unique pieces. And by looking at this in here, you see that by bringing in these statues, they really take the attention of the player away from a lot of repetition that is happening in here. And another benefit is that you have more optimization available for you, because let's say that, for example, in a game, you're going to have a lot of the buildings modeled and created uniquely without modularity. For example, each building being its own separate piece and using only once. You need only a lot of texture memory for this, and a lot of disk memory, and a lot of hardware space, because all of these have been created uniquely and you can use them only once. Or your environment is going to look really unnatural because of having, let's say that, for example, this building being repeated over and over again. It's really going to make it bad. But when you're going to use modularity, you're going to divide the buildings into smaller chunks. And these smaller chunks can have better texture resolution, they can have better details and things like that. And the only thing that you need to do is tiling them across to get the environment done. And this way, for example, for this environment, if you make it modular, you need to create only some textures. For example, here we have a tiling brick texture, and we have some concrete textures and door textures and things like that. You can create 3 different textures and create a whole building out of these textures. And this makes it really optimized. And the next one is the ability to test the environment early, and even without bringing in AAA textures and props, you can block out this environment if you have a proper planning. And you can test your environment to see how it works together. And this is a really simple example, basic example that I created. I have this tiling wall piece and this wall variation which has a window, and this wall that we can put a door frame in. So I have placed the pivot in here. Don't worry if you do not know what the pivot and the pivot system works. We're going to talk about that extensively later on. But this is just to clarifying the blockout phase, which we can test the progress early on. And I've created these are tiling perfectly, and since I have created them using some rules, I can test the progress early on, even without creating AAA meshes and things like that. And this way I can really test the environment to see if that is going to work or not. And let's say that you create a really beautiful door, you sculpt it in ZBrush and bring it in Engine, and to see that it doesn't work. And you get a lot of wasted time if you do not do this blockout stage. And this one is to make sure that everything that you have planned is going to work on together. Okay, we need something for them to snap. And the snap menu is in here. You go, and I'm going to snap to increment. So when I'm trying to move that, it's going to snap. Of course, I need to center them so that the snapping is in the center of the world. And now if I try to snap them, the snapping system is 1 meter. Every time I try to move this, it goes 1 meter in every direction. And this is very good for snapping. And later on, we will talk about the grid size and how to use that. So this is the simple wall, and this is a wall that has a door. I'm placing it, and you see that they fill each other very good. And I'm going to place it in here and right up just in here. And you see it fills the gaps. And since all of the pieces are really working great together, I have no problem snapping these together. So now you see I've created a simple wall that has a door and a couple of windows upstep with only using some blockout meshes. And this is good to test the progress early on to see if everything is going to work all right. And I feel like this is a necessary part to do, because without the blockout, you really do not have a strong ground to start from. And chances that you fail are going to rise too much. And you saw how with just some simple kits, we were able to model a building if we wanted to. And that is really a benefit of modularity. We can iterate a lot faster than having to model them one by one unique pieces. So I think it's about talking about modularity and what it is. And it takes some steps to create a modular environment. So the first step, as like anything, is just planning. You need to look at a lot of references and to see what type of modularity you want and what type of a game it is. You need to ask a lot of questions from yourself to be able to guess what you're going to create. For example, in this particular example, let's go for this simple one. And in here, you see this primary kit, which is a building kit, has some sub-kits as well. For example, it has the first floor kit, it has the second floor kit, third floor, and the roof. And there are a lot of repetition in here. You need to go and plan to see what type of environment you're going to create, what type of game you want to create. For example, if it's a game where the player is going to be able to interact with it so close up, for example, a third person or a first person, you really need to go deeper in modularity and take these and make them their own single pieces. That way you need to create a lot of kits. But this one, if you're going to create a game that is a strategy game, you might need to create a whole building as a kit and model that only once and use it in throughout the level, because the player is going to look at the building from such a distance, and that really doesn't make sense if you go and customize every single window. So you need to keep that in mind in the planning. The next step is the blockout. The same thing that we did in Blender just seconds ago. We go and create pieces, but we really do not need to add a lot of details into them. We are testing our ideas to see if they work or not. And when we made sure that the modularity is working all right, we go to the third steps, and that is really working on AAA props. We take those blockouts and turn them into AAA quality meshes and textures to really push the quality up. And there are some parts that are ongoing throughout the whole project. For example, lighting the scene, creating materials, creating interaction, creating blueprints and things like that. They're ongoing, but the three main steps are these ones. So I feel like this is enough for this lesson, and in the next one we will talk more about these as well. Okay, see you there. Okay, in previous lesson we talked about the modular environment design and found out that what modular environment design is, and really talked briefly about the concepts that might be important in the workflow. And at the end of the lesson we found out that there are 3 steps involved in creating an environment, and this is applicable to all types of environments and even outside the context of environment design. If you're going to do something, even doing some programs and things like that, these steps are still applicable. So the first step is the planning, and the planning is just like the foundation for a house. And if you just stack some bricks up together and call it a house, they're not going to last very long because the house doesn't have any foundation. And the same goes for environment design. You need to have proper planning in order to be able to execute the rest of the steps perfectly. And this planning stage might be overlooked by some artists, but this is one of the most important steps in every production. No matter if it's a film, movie, animation, game, or even outside of the CG context. For example, in your life, you're going to do something, you need good, proper planning. And now, what is the planning? So basically, the planning stage is the fundamental step in any project, no matter if it's a CG project or it's a real-life project. And it involves pre-thinking the final result. You need to have the final result in your mind even before starting the execution. You need to have the full environment in your mind, even without creating it. And for this one, you need to have a lot of imagination. And you need to pre-think the required actions to get that final result as well. Not only you need to finalize that final result in your mind before creating it, but also you need to have the required actions and steps to get to that final result. And the greatest point is that it gives you foresight, vision, imagination, and basically whatever you call it. And by doing a proper planning, you're able to close your eyes and fly in the environment even before creating it. So this is the formula. You have the basic raw idea in your mind. For example, when I wanted to start this one, I knew that I'm going to create some Victorian buildings. So I went ahead and did a lot of planning on that. And that planning involves in a lot of steps. For example, gathering references. And this gathering references is one of the most important steps that you need to take. And you might think that I'm going to create an environment without any references. And that is wrong. The more references that you have, the more and the better idea gets in your mind. When you're thinking about something, you have a basic idea. And then you need to do a proper planning to get to the final result. And as you know, this proper planning involves the vision. First, you need to have the vision in your mind. And then you assign some steps to get to that vision. For example, we know that in the steps, we need to assign what type of modularity we need to use to create these buildings. Do we need to create it chunk by chunk? For example, creating windows separately, which is the case for something like a first-person or third-person shooter, or creating a whole block uniquely for something like a strategy game. And basically, you need to sit down, bring in a paper, and write down any idea that you have, and think about your final product. And you're always interchangeably changing between the steps and vision. For example, you have a vision and start thinking about the steps to get to that vision. And then after completing the steps, you have a more crystal clear vision. And you repeat this until you get the final result. And I mean the final result in your mind, in your imagination, even before starting the process. And even before starting Unreal Engine or Blender to create something. For example, we need to create a Victorian type of building. We have the raw idea in our mind. So then we go to the planning stage, and then we have some steps. We go through the references and we see that we need to make it modular because there are a lot of repetition happening in here, and this makes it a perfect case for creating something like modular. And this is the vision. And after that, we decide, for example, we want this one to be a separate chunk and this one to be a separate chunk, and tile them over to get the environment that we want. And you repeat the process again and again until you have the crystal clear image in your mind. So after all, this planning stage is all about imagination. And this imagination means that you have a clear image from the final product in your mind even before starting to create something. You need to think as much to create this vision for yourself. And how do we do that? Your primary weapon in this part is the questions. And that goes in something like this: questions, questions, and more questions. And you need to sit down, bring in a paper, and start to write a lot of questions from the project. And it's generally a good idea to start from broad questions, from general questions. And the process should be something like this. You start with bigger questions and general questions. For example, in which time period this environment is going to happen? This is a very broad question. And we answer that question by, well, we're going to create a Victorian environment. So what type of Victorian environment? What type of building? How many floors do we want the building to have? Basically, the first question was very broad question. What type of environment we are going to create? Do we want it to be a prehistoric environment? Do we want it to be a sci-fi environment? Do we want it to be a new environment, old environment in terms of clean or abandoned environment, and things like that? You start with broad questions, and then after asking yourself some general questions, you come down to the specific questions. For example, in the previous step, we answered some of the general questions. For example, we know that we are going to create a Victorian building. So what type of Victorian building do we want it to be? Do we want it to be a general store? Do we want it to be a residential store? Excuse me, a residential place? Do we want it to have a lot of ornament works just like this one? Is it abandoned? Is it new? Is it something mixed with the sci-fi flavor? And a lot of questions. And then after answering these specific questions, you really go down to very specific questions that belong to the environment. For example, I need to create some decals to answer this question. There are a lot of dirt in here. How do you want to tackle them? And things like that. So what type of questions you need to ask from yourself? So the question is that, how do we provoke these questions? So we need to categorize them in 3 different categories: what, why, and how. The what section is basically the most essential questions that you need to ask from yourself. And as you know, you need to start from very broad questions all the way to specific questions. For example, now in the what category, and these are some questions that you can ask from yourself. In the first place, first you think of, well, what am I going to create? You come with the question, and the answer is, well, you're going to create an environment. What type of environment you're going to create? Well, modular environment. What time period? This belongs to a Victorian era. And this even introduces a lot of sub-questions. For example, we decide that we want to create it in the Victorian era. So what type of building? Do we want it to be a bookstore? Do we want it to be a hotel? Do we want it to be a general store where a lot of tools are sold? And the next question is that, if you want the environment to be old or new, or how many stores do we want it to have? And then what inspires you to create that environment? And you need to find those in the references. And then about weather conditions. Do we want it to have a rainy environment or a stormy environment or a day or night? Basically, you ask yourself a lot of questions and write them down so that you have a clearer image in your mind. And after knowing what you're going to create, you need to ask yourself why. So for the why category, we have basically, why am I creating this environment in the first place? For example, you want to create it for a portfolio piece or an art challenge or anything. And you might have the goal to take your environment art to the next level and creating some AAA art, whether it's materials, textures, geometry, and anything. And why am I going to create this environment? To learn modularity, or for learning Unreal Engine 5, basically what it does. And I set the goal to have a better sculpting. in ZBrush basically, and utilizing Nanite and Lumen. And you know that the Nanite is the virtualized geometry mode in Unreal Engine where it allows you to bring in high quality film props without any optimization, and the Lumen is global illumination that is dynamically changing without any cost. So these are the goals that you set for yourself. So how to get to these goals? You look at these goals and ask some questions. So you know that we're going to create modularity. So the question rises that how do I want to hide the repetition in modular environments? How to use vertex color data to add variation into modular kits? How to author PBR materials, maybe in Substance, maybe using ZBrush or Photoshop or basically anything. And for example, utilizing Nanite and Lumen, the question rises, well, how do I want to create AAA meshes for Nanite? And I'm going to extend this part, for example. We're going to create meshes for Nanite. How do we create them? So this is the answer that you may come up with. We're going to create the low poly in Blender and do the high poly sculpt in ZBrush and do the UV in Blender again and texture it inside Substance, whether the designer or a painter. So basically you ask a lot of questions from yourself, write them down to conclude the environment that you're going to create. And one of the devices that can answer a lot of your questions are the reference images. And these reference images can answer a lot of your questions. For example, what type of environment do we want to create? We go look at the references and get inspired by this building, for example, and we learn that we want to create a Victorian environment. And now that we know that we have the Victorian environment in mind, it's time again to go from very broad to specific. And you need to go again from this step all the way to the specific. You first look for the big pictures, then medium pictures, and then small pictures. And anytime that you're creating art, you want to have this in mind. You go from big to medium to small. And to visualize that, you need to have a shape in mind. And that shape is this triangle. You see down the bottom of the shape is very big. And it's holding the whole structure from falling. And this is the big ideas of the environment. This is the big section. And know that this broad section is holding the ground. And this section is really the beautiful part of it. Then after big, we have the medium. And then we have the small portion. So what do we mean by this? When going for references, we know that this is the big picture that we want to create. And the big in composition is something that holds out from the far view. For example, if you zoom out, you're able to distinguish the parts. We know that this is a building. If you look at from so far away, you're able to distinguish the composition, anything in the picture. But this is not good for environment creation. For example, if you're going to create a concrete material to support this building, we need to have some references from the textures. For example, we need close-up images to really see what is going on in the medium shapes. And something like this is good. For example, we zoom on it and see how many bricks does it have. Or for example, this one, we zoom on it and we're able to guess some of the wear and tear that is happening in this image. For example, we see a lot of dirt in here. And then, for example, such an image is really good for creating textures. We are able to guess the really small, tiny shapes that create this texture. You know, from going from this one that has broad shapes and bigger shapes, we go all the way to this one, which has some smaller shapes when we go to create some wood textures. So you need to have that in mind. First, you need to have something that holds the environment. First, you need to have a structure, a big structure, and then medium details, and then a small details. And when you go and see a piece of art that is created, you see a lot of details, and that detail happens in this part, this small part. But the small part isn't going to hold on if it doesn't have a big shape. And if you start to create the environment using a small shapes, using a lot of details, you might find out that you do not use it and throw it away, and you have a lot of wasted space and time. So you want to start with the big, go to medium and a small. And after answering all of these questions, we go to the blockout phase. And this blockout stage is mainly working with primitive shapes, for example, working with cubes, working with cylinders, main shapes, planes, and things like that to prototype to the environment. And this is done mainly to test the idea. After deciding that we're going to create the modular environment and answering all of our questions, we finally go to this step, and by looking at the references that we have, we start to block out the environment. For example, if you're going to do something like this, just have the piece in mind. We go ahead and we know that we have a lot of windows. We take this and bring it up top. Bring it up top of this one, and then start to duplicate these to get the result that we want. For example, instead of creating that building fully, we only create the big shapes so that we know that the environment is going to look functioning and great. For example, now look at this, and now look at this. It's the same thing, but first, instead of creating this intricate details and a lot of texture work and things like that, we need to first create the blockout, and after that we made sure that the kits are functioning and they snap together very well and we do not have any problem. We start to go and create the AAA props and textures, and this is really what the blockout phase does. And one benefit of this environment, this blockout design, is that you can iterate a lot faster than creating AAA meshes. For example, let's say that we want to change something about this wall. If we created the mesh fully and without a lot of things, we would have a lot of wasted time. And let's say that we created this fully with textures and with all of the details. Let's say that we wanted to change something about this wall. We would have to go and again do the low poly in Blender, do the sculpting in ZBrush, texture it, and bring it in Unreal Engine to test it if we didn't use the blockout meshes. But now we are only using a simple placeholder mesh. And let's say that, for example, we wanted to make this window bigger. We simply take it, and there are everything just about manipulating some vertices. I take them, make the window bigger, and then it's the matter of placing this one with other meshes, only with just some clicks, instead of having to put a lot of time in the making process to make it look good. So this faster iteration helps a lot to iterate into the environment using these blockout meshes. So I believe this is enough for this lesson. We talked a lot about the planning, and the next one we will go and do the blockout. Of course, that is an ongoing process, and we're going to do that in multiple lessons, but we start the process pretty soon. Okay, see you in the next one. Okay, in the previous lesson, we talked about the planning stage and how important that is, and how really you can fail a project without the proper planning. And now we are ready to move on to the step 2, which is the blockout. And this one is really important as well. We decide on the planning and then move to blockout to test the ideas and to iterate a lot faster. And in the previous lesson, we thought that it's a great idea to move to the blockout stage before creating the AAA props and textures, to save a lot of time and make sure that everything is working together. Okay, now we're ready to move on to the blockout phase. And in this blockout phase, we are mainly working with primitive shapes. Just like the example that we build here, we're working with primitive shapes with really no geometry or texture or any details. We're only giving the big shapes, importing and exporting into Engine to make sure that everything is working correct. And when we made sure that everything is all right, we start to iterate on top of each other. For example, we have the first one, and let's say that we want to add a bit of detail. We duplicate it and isolate, and let's say that we want to add a top piece into this wall piece. We simply go, and since we really do not have any geometry, it's a very easy task. All you need to do is working with some really simple geometry that is easy to work with, instead of using, for example, those AAA meshes and props and things like that. For example, we wanted to do a custom piece in here. We did it. So simple. And then go back, and now we have the piece, and it's separated from this one as well. And it's a lot easier to iterate in these parts because we really do not have a lot of complicated geometry, and it's a lot faster to iterate. For example, we have this kit, and now creating a window is only a matter of adding a couple of polygons and then removing that. And then, for example, if we wanted to add a door piece, for example, let me go back so that we have this piece untouched, and let's say that we want to create a door piece. we go here, and since we have the logic, we only need to work with some polygons. We bring it here and totally remove this one, and then remove this one to get a door frame. And since all of these snap on a grid, we're really having no problem iterating, and anything would be all right. So let's say that, for example, we're going to create a window piece. We get it, remove that, and boom, we have the window piece. And we can iterate a lot faster compared to having finalized meshed. And this one is really to test out the ideas and make sure that the modularity and the logic that we create is workable. And it's in here where we have to decide on the UVs as well. And the process is a lot easier when you take one and finalize it and then try to take variations from it. For example, we have this one, and if I'm going to decide to add some textures on this, the UVs are not in place. So I need to take this and remove it and bring one initial piece. So let's again duplicate it and let's look at the UVs. And since this one is a simple plane, the UVs are really there from 0 to 1 UV space, and that has a default UV. It's all right, and because it's 0 to 1, it's going to tile perfectly. So by that I mean, if we go in here and try to add a material, let's go add a base texture and an image texture, and from here I want to bring in the base color, and let's go to the material mode. And this is not the best example, but you see that this texture, since this texture is tiling, if I decide to duplicate it and bring it here, although these are two separate meshes, but we are not seeing any tiling issues in here. You see there's a seam in here, but since the texture is tiling, we are not really seeing the seam in between them. So making the UVs correct is the best thing that you do to avoid a lot of problems. So let's take this one as an example, and now let's duplicate it. Or let's remove that and try to add some things in here. For example, let's do the same thing that we did there. I'm going to take this one and extrude it just a bit. Let's remove the snapping. And this is what we get. For example, and I did the same thing and I welded these to give it a bit of shape. And I'm going to take this and add a bevel to make the shape a bit interesting. So this is it, and now you see in here we have a bit of problem. That is because we created a geometry and this really doesn't have any UVs. So I'm taking this, right click in here and unwrap. And now you see this happening in here. And since this is too big, I'm going to resize the UVs just a bit to make that perfectly work with that one. So you see here, and now let's go in here as well. Let's go back to this piece, or if you want to save a bit of geometry and texture space, you can take it and delete it, because when we snap this, when we go back and try to snap this, since this is going to snap together, that part isn't going to be seen here because these parts collide together very much that this part gets deleted. So I'm going to take this and go in the geometry mode and remove this, and we have a part in here which we need to fix. Right click, unwrap, and we get a good texture. So let's say that this one is a good base that we are happy to work with. Now the thing that we need to do is going and do the iteration, and since these were tiled very perfectly, we have no problems. So I'm going to take this, add a couple of vertices to be able to add the door in, and now let's take it, and you see, because we are moving these vertices, we are getting the texture stretching. We do not want that, so we need to use a sliding mode. So let's take this, and in my case, you need to tap G sometimes, and now you should use this slide mode without any problem. So I'm taking this one as well and use the slide mode. Now we have the frame for the door piece. So I'm going to add another in here. And since we're going to take the window from this one, I'm going to copy that and start to work on this. So I delete this part and the door frame is available. And now let's go in here and try to add the vertices in here to be able to remove this polygon for the window. And now you see, although these are tiling pieces, we have no problem between the pieces and the texture is tiling perfectly. You see in here, we have really no obvious issue. And this is the power of using modularity with tiling textures. And the good thing is that if you go and try to tile texture more, it's a non-destructive process. So let's go in here and bring up the shader editor. No, let's go and try to export these to Unreal Engine to test them there and create a tiling material to learn some things as well. So if you are going to export this to Unreal Engine with the default Blender settings, you're going to have some problems, because first thing, you need to center this in the center of the world. And if you go in here, just hit N to bring the transform menu on, and you see in the location we are negative 20 meters off from the center of the world. So if you want to center this one to the center of the world, you need to hit Alt and G to make it go to 0, 0, 0. And anything needs to be zeroed out. And if you export this one from here, you're going to have some pivot issues, because the pivot is in the center of the world and this object is 20 meters off from the pivot. So let's export using this to see what happens. So now I'm going to go to export and export as FBX. And if you want to access this faster without needing to come into this menu, you need to right click and, for example, right click, add to quick favorites, and in here to access the quick favorites you need to press Q. And now I have some objects in here. I have the FBX import and export in this menu, and of course OBJ as well. So I'm going to take this one, export as FBX, and right now I really do not care about the naming convention. I'm going to only select this and limit the export to selected object, because if you do not check this on, it's going to export anything in the scene. So we select this only to export this one. So I'm taking this and let's name it 01 and hit export FBX. Okay, it exported, and now let's go to Unreal Engine and try to import that to see how it works. Okay, here we are in Unreal Engine, and this is a default scene. I'm going to go create a new scene, a new basic scene, so that we have a lighting system to work on. Okay. To bring up the content browser, you need to hold Control and a space to bring this up. So we need to be careful about the folder creation as well. I'm going to go under the content, create a new one, and let's call this one Modular Victoria. Okay. And in here, let's bring in a subfolder and call it Meshes. And I'm going to again bring in a folder and call it Blockout. Okay, and in here I'm going to hit import and go to the file that I exported and import. Okay, we're not doing anything with these. Let's hit import. Doesn't matter for the error, and it also brought the material for us, which is a good thing. So let's bring it here, and in here you're not seeing anything. And why that is? Because this is now the center of the world in Blender. Let me go in Blender, and this is it. This is that pivot. And because we have offsetted this one negative 20 meters away from the center of the world, we should look at there and we should be able to see, yes, this one is the door. And since it has been offsetted from the center of the world, we are seeing this problem. And the pivot is in here. If we try to rotate this or resize it based on this pivot, we are going to see a lot of errors. So there's a plugin that makes it easier on us for exporting FBX, and that is the BatX plugin, and you can find it here. And it's a free plugin. You can grab it from GitHub. All you need to do is downloading this file, and after downloading you get a file, and it's a zip file. And then in order to install it, you go to Edit, Preferences, and in Add-ons hit Install, and just head to the folder where you have downloaded the file and just hit Install Add-on, and it gets installed for you, and you can find it here. Just search for BatX, and this is the BatX, and it gets added to this N menu in here. You can hit N to bring it up and hide it. You can find it in here, and in here it has a great option to center the transform. And if you enable this option, it's going to first, before anything, center that and then export it, but it's not going to do anything with the mesh. It first temporarily brings this in here and then exports that. First you need to specify a folder. Just go to any folder that you have, and let's take this one, hit F2 to be able to rename it and call it 01. And then apply transform is going to apply all of the transformations. For example, this rotation and anything, it's going to apply the transformations on them, make them 0. And on the scale, make them 1. So that we have the size consistency throughout the project. And then we have another option, which is the one material ID. And it's good for the times when you have only one material ID. In this case, for example, we have only one material ID. This is here. If you add multiple material IDs, for example, let's suppose that this one is a new material ID. You want to check this one off if your mesh has multiple material IDs. So now that we have the mesh in here, the pivot is working all right, and we will talk about the pivot as well. So I'm taking this one, rename it to 02, and this one rename to 03. And this naming convention is very important as well. You need to have a naming convention that is readable and findable as well, so that when you look at the name of the mesh, you know where it belongs to and what it can do. So let me take this one and hit export. Take this one as well, hit export. This one as well and hit export. And now let's go to Unreal Engine. And since we overwrite this one using that, we go in here, right click and hit re-import. And now it's gone to here. Now the pivot is working all right. And now let's go to import others as well. Right click and hit import. And now these two are available as well. Import all. And now we have these pieces as well. So let's select them, bring them all in. And now you see the meshes are colliding because all of them have been centered. And that is perfectly what we want. So the next thing that we need to do to make these work is assign the grid size and the snapping option. Because now if I select this one and try to move it, every move that I do is 10 centimeters based on this menu that I have. And this is the snap menu and this is the grid. If you disable it, you are able to move it freely without any problem. But if you want to work modular, you need to have the snapping on. So let's go to 100. And now the grid is now much bigger. Of course, we will talk about the grid and how to set it up as well later on when we create the real stuff. So now that I'm taking this, every time that I move this one, it's going to offset 1 meter. And since these are 2 meters, these are 2 by 2 cubes. You see in here, every cube is 1 meter. These are 2 by 2 a square. So every time that I move this, I'm moving a couple of meters, 1 meter, excuse me. And now let's take this one and bring it here. Now let's say that I'm going to bring this one here and bring it up. Let's copy this one, and you see we created a very basic modular kit. And now I'm taking this wall and try to extend it. And you see, since the texture is tiling, we have no problem. So let's go to the material and let's say that we want to make the tiling better. So there's a node. You can hold down U and right click to bring in the texture coordinate node. And this is going to decide on the tiling of the texture. So if you're going to change the tiling, you need to change it in here or do something better. Hit multiply. And now everything that you multiply is going to multiply the textures. The default one is 1, so you're not seeing anything. I'm going to bring in a constant and make it, for example, 2. Okay, now that I make it 2, now the texture is tiling twice instead of once. So now if I go in here, you see the texture is tiling twice and we're not getting any problem in the textures as well, because every time that we try to tile it, all of the kits are going to tile together, because all of them come from the same one. If you remember, first we created this one and dealt with the UV, and then after that did the next ones from that. And it's always a good idea to create the first kit, the first module, and then after doing the UVs and pivots and things like that, take the variations from that. That way always you have the consistency. And you need to have the pivot in mind as well. The pivot should always stay the same. And when you decide on the pivot of something, it never should be changed. For example, now I have centered the pivot, placed the pivot on the bottom left of this object. And anything else has the pivot on the same place so that they snap together very good. So if you go and alter the pivot, for example, now I have altered the pivot on this one and export it. And the good thing is that when you export, it's going to automatically overwrite that file for us. So I have exported the 03 Now let's go into Unreal Engine and take the 03 and try to re-import it. Now you see they have been altered because the pivot of them has changed. So always you need to have the material, the UVs, pivot, and the naming in mind, because these are going to maintain the connection between the DCC app and Unreal Engine. So let's go in here and again bring the pivot in here, export it. Now let's go to Unreal Engine, again hit re-import. Now they went back there because the pivot is now here. So you always need to have those in mind. And let's say that for any reason we come in here and try to go in this door frame and try to offset the pivot just a bit. So let's go into UV editor and try to select all of this, and this is the file. And now let's try to resize the UVs just a bit. And now since the UVs are different from these, let's export this one. And now let's go to Unreal Engine and try to re-import that door frame. So now that I've re-imported, you see that we get a harsh seam in here where the connection of this one and this one happens. And that is because the UVs have been altered. So you need to make the UVs tile together perfectly. So do not worry about these concepts. We're going to talk about them extensively when we go practical. But these are the things that you need to have in mind. And now one thing that you see is because we are using a tiling texture, we are seeing a repetitive pattern happening in here. You see 1, 2, 3, 4 tiling textures being here. And this is one of the weaknesses of the modular approach. You're getting a lot of repetition because the tiling texture and the tiling geometry makes that happen. So you need to do a lot of tricks and a lot of magic to make this go away. So let's go in here and try to offset the UVs to be better. And now even in here you see that there's a harsh seam in here. So you need to keep the UVs consistent throughout the project. So this one is it, export, and now go in here and try to re-import that. And now that issue is gone and we're no longer seeing the problem. And one of the important benefits of this one is the fast iteration. So besides from being able to create different variation, he can take one mesh, for example, and do changes, and that changes will be reflected back in Unreal Engine in no time if you use this method. So let's go in here, and this is what we have. So now I'm going to take a duplicate in case just something goes wrong and have this one as a backup. So I'm working on this one and not this one because the name has been changed. I'm only going to work with this one because if you export this, it's going to give you another FBX. And this is basically what you get. And this is really not what we want. So always you need to overwrite the same file without any changes. So now let's say that I'm going to take this one and do another variation. For example, taking this and create some changes in the geometry. So let's do some manual small changes. For example, creating a frame on top of this one. I simply take this geometry and take this one and bring it in. Of course, since I'm using a snapping, it snaps 1 meter away from the surface that I have stretched it from. So I'm going to bring it here, and now I have a new piece, and now I have manipulated that piece. And right now I'm not caring about the UVs because we learned how to do the UVs as well, how to correct them and things like that. So I'm going to take this, export it, and now I go in Unreal Engine and boom, let's right click and re-import. And now you see that change has been reflected here perfectly without any problem. And this fast iteration is something that we're going to use extensively later on. Instead of bringing in the mesh and try to replace it, we only change in the mesh and hit export and overwrite on top of the previous file to do the iteration. And this way we're able to finalize the meshes, and these blockout meshes are going to stay in the place. And the same thing you can find in these references. For example, we start with the simple blockout, we do a window, just a window piece in this blockout, and then do the iterations on top of that. We add these intricate details, we add the texture work, we add this paneling, we add these ornaments and things like that. And after some time, you see the building come to completion. Okay, this is enough for this lesson. It has already gone beyond 20 minutes. We talked about some general rules to follow. For example, making the geometry using only primitive shapes, and briefly went over and talked about pivot, grid size, naming convention, transformation, and tiling material. Especially for these three, we really didn't talk too much. And in the next one, we're going to talk about these extensively. And this blockout phase really has some awesome benefits. You can iterate pretty fast, and as you saw, we are able to change something and export and boom, get it in Unreal Engine. And if there's any problem, you're able to fix that pretty early on because there's not a lot of texture, shader, and geometry being in place. You're only working with some simple shapes, and the problem fixing is going to be pretty fast. And then after that, you're able to test your ideas to see if they work or not, if they become modular or not. So if you went and test your idea and found out that it doesn't work, again, you go back and fix it. And by fixing, I mean creating another variation or bringing another kit to fix the idea. So then you can see the environment quickly. And you see in here that more or less this is going to be in place to the end of the project. And anything that you do and evolving the mesh and finalizing it is going to be replaced on top of this one. And now you know that this is the environment and you're going to be good playing the gameplay. You're able to do a lot of things. For example, this is a door. Of course, since this is a 2 meter by 2 meter, it's very small, but you get the idea. And you're able to test your ideas and play them and to see if anything works or not. And this is pretty good to be able to test the ideas early to see if there are any problems, you solve them. And if everything is good to go, you go and start to refine the textures, refine the meshes, and do all sorts of things. And one of the most important ones is getting motivated, because you see that the idea is taking shape, it's going to work, and it's practical and beautiful as well. When you have this one, for example, you see that the environment that you're creating is getting shape, you really get motivated and see that the environment is coming to life and it's going to work perfectly, you see, and you get motivated throughout the project. And of course, the changing is pretty fast. If you want to change a module, you go to the content browser, select this one, for example, and swap it with no problem. And since everything is tiling, you're going to have no problem. So, for example, if you're going to select it and make another floor, is just easy. So take them and try to replace the modules to create what you want. You see, pretty fast we were able to do a simple building only using 3 modules. And this is very good to look at, to see that your idea is going to take shape and it's going to work. Now, the only thing that you need to do is creating beautiful materials in Substance, making great textures that tile, making the tiling geometry, and so on. And now, since we are using nanite, we are not going to use a mesh like this. You see, this one is a tiling mesh, but there are some problems in it. And if I go into the wireframe, you see that there's really nothing much in here to look at. So let me go in here and try to look at the wireframe mode. You see, this is a very, very simple geometry. It's pretty flat and you're not able to see anything. But this is the easiest method to work with. You know that you have a geometry that works. The vertices in here have a counterpart in there as well. That is why your geometry is going to work. But if you add something and offset these vertices in here, and if I try now to duplicate this, let me bring it here. Now you see a gap in between these because the vertice doesn't have a counterpart in here. So using these flat planes is very easy to get it done without any problem. But we're going to do a more difficult and more attractive and newer way, and it's adding a lot of geometry. We're going to use tons of geometry, and those geometries are going to be handled by nanite to make the optimizations. But we're going to add a lot of geometry. For example, for this part, we need to add geometry, and we're going to do that when we do the real production. So this is what you need to do to get the blockout down. And in the next one, we talk about some technical things. For example, assigning the pivot, the grid size, naming convention, and things like that to make the project consistent throughout. Okay, see you there. So in previous lesson, we talked about the blockout and how to use it and how beneficial the blockout is to our project. Now we're going to talk about really how to create these blockout meshes. And now we're going to talk about especially the pivot, grid size, and naming convention. And when you decide about these, especially for pivot, grid size, and naming convention, you need to make them consistent throughout the project and do not change them ever, because you're going to break the modularity and break the project consistency as well. So first, let's talk about the pivot. And every geometry that you create has a pivot by default. So let's go in here and create a plane, and this plane has the pivot in the center. And you might like the pivot to be in center, or you might want to offset the pivot to somewhere else, depending on the needs of your project. For example, if you want to rotate and snap your pieces from the center, the pivot should be in the center. For example, in such a case, we have something like this. Everything now is snapping perfectly and it's snapping to grid. But if we take this one and let's say that we want to rotate this, it rotates from the center. But if you're going to create a wall, for example, that the wall is going to tile in this direction, the pivot needs to be somewhere in here, in the bottom left, so that when you copy it, it snaps from here. And if you want to make a 90-degree corner, it's easy just to rotate it and create a 90-degree corner. And it's a good practice to always have the pivot at the same place for all of your modules in the kit, because it makes the consistency. For example, even if your geometry doesn't start from here, let's let the pivot to be in here. For example, let me copy this one to tell you by an example. So I'm going to bring this one up, and let's say that we're going to create a window in here. That is very simple. I'm not going to do anything special. Okay, this is the place for window, and let's say that we want to detach this one for the window. So I detach it, and now we have the wall with the pivot, and it's all right. And we have the window as well, but the window doesn't have the pivot in the center. So for example, something like this, the pivot should be just in the same place according to the kit. For example, these have the pivot in here, and the window as well should have the pivot in here, because let's say that if you want to copy this wall and bring it in here and snap it to here, instead of this one having the pivot in the center to bring it here, it's always good to have the pivot in here. And it's not just so easy like this one. I bring it here and it does something like this for me. For example, let's duplicate a window and place the pivot in the center. And let's say that we offset this one to something like this. And if we want to bring this window using this method, we really have to go in here and try to find the window and put the door in here, put the window in here in its own place. It's going to have a lot of hardness to place this window just the place that it needs to be. But if we have the pivot of the window as the same as the piece that corresponds to, we only need to place it on the grid, and it's going to be fast placing it right in the place. For example, now I'm going to place it somewhere really random in the world. So if we need to place the window in here, all we need to do is center this one and now turn on the pivot, turn on the snapping, and now we need to bring it so that it fits the place perfectly. So it's a good idea to make all of your kits in the same category or in the same modules to have the same pivot, to stay consistent throughout the project. And never ever try to change the pivot after deciding on what it's going to be, because it's going to ruin your project. So this one was for the pivot, and now the next one that we need to talk about is the grid size, and this is as important as pivot. And the grid size is basically the maximum extent that you decide for your kits to be. This grid size is an imaginary box that all of your modules should fit in order to snap together perfectly. And the easiest grid sizes are sizes that are equal in both X, Y, and Z. something like 2 by 2 by 2 in X, Y, and Z, so that all of the height, width, and the length are together equally. And let's explain that in here. So you see in here we have this grid, and this grid in Blender by default is 1 meter by 1 meter. And to decide on the size of the grid, if you want to make it larger or smaller, you need to go in this menu, and in here we have the scale, and this represents the 3D grid. And one more important thing that is basically very important to do is going into this scene properties, and in the units you want to set it either to metric, length to meters, or centimeters. And now in here length has been calculated using meters, and now if we go in here, the scale is 1, and 1 is 1 meter. If you make it 2, it's going to make the grid bigger. And if I take this one, and now instead of only moving in 1 meter, it's going to move in 2 meters. You see, it's going to move in 2 meters. And if I make this one, for example, 0.5, it's going to have more grids, resulting that to have a smaller grid. So you see now it only moves half a meter, which equals to 50 centimeters. So you need to decide on the grid size from the beginning. Of course, this doesn't really do much because this is only imaginary in Blender. For example, if you're going to make the environment in Blender, of course, it's good to set it to 1 or 2 or 4 or basically any value. And as a rule, I'm telling you that always keep your numbers in multiples of 2. For example, 2 by 2 by 2 or 4 by 4 by 4 and 8 by 8 and by 8. And of course, you can go by 3 by 3 by 3, but you're going to have some problems. Of course, not problems. For example, if you're going to alter the grid size in subkits, you need to go and multiply these values. And in order to pieces to snap together perfectly, the numbers of the dimensions need to be multiplies of each other. For example, a piece that is 2 by 2 by 2 can snap to a piece that is 4 by 4 by 2. And by that I mean, let me create a cube, and this cube by default is 2 meters, and it means that it's 2 meters in every direction, 2 by 2 by 2. And let me copy that, and now I'm going to multiply that in X and Y. So I'm going to scale it in X twice and scale it in Y twice. So you see that now this one is a lot bigger than this one, but this one still can snap to this without any flaws. So I'm taking this one, bring it here and bring it here, and you see, since the values are multiplies of each other, they're going to snap together perfectly and leaving no gaps. But if you make it, for example, 3 by 3 by 3, if you make the odd numbers, if you're going to multiply them or divide them, you're getting these bad numbers that have decimal points. For example, 1.5 by 1.5, you're getting decimal numbers and not whole numbers. So in order to make it easier for yourself, it's a good idea to use the multiples of 2, if possible. But if the project doesn't allow, just go for something that you're happy with. And now you see how grid size is important for making these snap together. So let's say that I have these two pieces and I'm going to copy this one again. Now it's going to tile together perfectly. But now if I create a piece, let me bring in a default cube again. And this cube is, instead of being 2 by 2 by 2, let's make it 3 by 3 by 3. And now you see that it doesn't match the proportions. And let me make this one too to match that better. And although you see it has problems snapping to the grid and it doesn't match the grid perfectly, and if you do something to make it really there, you're going to have a lot of space that is either positive space or negative space, like here, and it's not going to snap perfectly. And if you duplicate it again, it's going to have some bad geometry. So you need to make the grid size always have the same multiplies. And again, you can stick to the 2 by 2 by 2 or 4 by 4 by 4. And that grid size is really an imaginary box. Let me go and create a cube, and this cube is 2 meters. Let me make it 4, and now we have a 4 by 4 by 4. So let me go in here and place the pivot down the bottom and make it centered in here. So let's say that this is the grid size, and everything that we do here should match the proportions. Now and it's a good idea, it's a good practice, although not necessary. It's good to place the pivot on where you want the pivot to be. For example, if you want the pivot to be in the bottom left, just place it in the bottom left and you're good to go. So place it in here, and now let's say that we want to create a wall that is 4 by 4 by 4. That should be placed in here, and it should especially stick to this part, to this length and width, so that it can match the coexisting kits. So in here I'm going to bring a plane, and now I'm going to make this one 4 by 4. So let's go in here and rotate it, bring it up, and now we have a kit that really gets placed in here without any problem. And this is a kit, but now the pivot isn't just in the place that we want it to be. You see the pivot is here in the bottom left, but this one is in the center. So in order to borrow the pivot from this mesh, you first select the target mesh that you want the pivot to be there, and hit Shift and S, and let's make it harder by bringing this to another place, for example. Okay, let's bring this one as well. Now the pivot is in here. So this is the pivot of the world. We need to offset this pivot to this pivot so that we can borrow the pivot from here. So you're going to understand it just in a minute. I'm going to select this, hit Shift and S, and now these two are going to manipulate this circle. So what I'm going to do is bringing the origin. This circle is called world origin, and the origin is basically the pivot point. So I'm going to bring this one to selected. Now it offsetted this from here to here. So now what we need to do is selecting this one again, Shift and S, and now this point represents the origin of this one, which is this orange point that you see here. So we set this one to cursor, and now the pivot is in here. And now I'm going to do something else, bring the cursor or world origin into its place, and now both of these are having the same pivot. You see, I borrowed the pivot from this one, and it's perfectly all right. So now let's set that this one is a kit. Let's copy it to another place, and again I'm going to do that example and create a door. Just a simple example that is not going to take a lot of time. So let's say that we created a door. I'm going to add just a couple of variations. So I'm going to take this one and delete them. So this one is a variation as well, and it has the same pivot. Okay, I'm going to duplicate this and bring it here, and let me take this one, duplicate it over, because I can make a window out of this one. So let's select these two, right click and bridge edge loops. Okay, it created a window as well. So the window, I'm going to make it a bit smaller, something like this. Okay, now we have 3 pieces, and now let's say that we want to create some subkits. Let's go look at the references, and in here you see that in such a place there is a floor kit as well. It doesn't connect to the top piece with anything. You see, it's the ceiling of the bottom floor, and this is the floor of the top floor. And in here we have something that stays in between. This is the ground, and we could go and try to attach this just using this method. For example, try to attach these walls, but if the player goes in, we are going to have some Z fighting. For example, if I have ground to be in here, let me again duplicate it and try to put it in here. Let's say that this is the floor of the top floor. But what about the ceiling of this one? The ceiling and this floor are going to have some Z fighting. And you see, 2 meshes are on top of each other. So in order to remedy this, there's some subkits that you can use to put some spacing in between these, so that these are not Z fighting meshes, so that we have something in between. So this is the time where the subkits come together and we can go and create variations of the grid size. For example, now that we have 4 by 4 by 4, we know that everything, for example 2 by 2 by 4, can snap to that. For example, a 1 by 4 piece can also snap to that. So let's go in here. I'm going to take a duplicate in case we lost something, and this is a 4 by 4 piece. I'm going to take this one and bring it down so that now what we have here is a 1 by 4 piece, 1 meter in 4 meters. So let's go back and let's first add just a bit of geometry details in here just to make it a bit more beautiful to look at. This one and this one, so just like this one. And now because the pivot is in here, I can take this one and just snap it here without any problem. Let me bring the snapping on, and now without any problem you see that it goes in place and acts as a place in between these. And it's good also to have some authentic flooring in here. So let's connect these two pieces together, and I'm going to duplicate this one again. You see it goes and it flows, works with all of the kits together. So this one as well. And now let me take this window, bring it up, and this also adds a bit of a spacing in between the floors. And now let's say that in here we want to add a couple of walls, for example a couple of smaller windows. So a 4 by 4 can also support 2 by 4 or 4 by 2. So let's go in here, bring this one. I'm going to take from this and bring it right in here. And now this is a 4 by 4. Let's take this one and bring it in here. Let's decrease the size. And now this one is a 2 by 4. And this perfectly supports here. So in order to make it authentic, I'm going to add some windows so that we know that we are doing. So I'm taking this delete, and let's say that these are some couple of smaller windows. So I'm taking this, bring it in here, and since the logic works, 2 by the 4 snaps in here without any problem, and since in here is 4 as well, 2 by 2 means 4, and now we get a piece that is working perfectly. So it's all about playing with numbers. And even if we wanted to create a third floor, we can take these, bring them up. You can go ahead and start to make a third floor as well. And if the gameplay needed something, you can do that as well. For example, let's take this one and bring it here. Now we have a 4 by 4 piece, but let me take this and bring it to the top so that we have a 6 by 4 piece, and that doesn't matter as well. As long as it snaps together, it's going to work perfectly. And now we have a 6 meter wall in here. And let me again go and add a couple of windows and duplicate it across, and now you see we have variation in the building and it looks less repetitive than the previous one. But if you're going to try to duplicate another of these 4 by 4 meshes in here, it's not going to work because it has a bit of empty space. But if you are going to cover that, it's easy. Some pieces that should snap together to fill the spaces. So as long as your mathematical calculations are alright, you're really more than welcome to do anything as long as it snaps together and functions right. For example, in here the floor should be the same. Let me take this, bring it up again. So as long as the floor of these share the same logic, it's all right. For example, if the player is in the building itself, let's say that this is the view of the player, this is a window, and this is a window. As long as the floor and anything is working all right, as long as the floor and the ceiling are doing their job pretty well, it's really not a good problem. It's not a really huge problem. So the mathematical is all right. You're going to have a good time. So this is the blockout, and now you can take it and do whatever that you want to do with it. You can iterate on it. You can do a lot of things. And now something about the naming convention, because it's very important. For example, if you go into Unreal Engine and I start to look at this, the name in here is 03, and it doesn't actually work. When you're looking in the content browser, you're not really going to guess what this module is going to do. So you need to invent a naming convention to make all of these readable as possible. And you want to make it not only readable, but easy to understand and distinguishable from each other. For example, let's go in here and we have some kits in here. Let's say that this is a wall piece that we have. This is a wall and window. This is a window, and this is a wall and window again. So I'm going to take this and delete it. Let's say that we have three modules in here that belong to the same kit. And knowing that all of these are coexisting, they are going to be together just like this one, having the same material existing alongside each other and so on. So to make we go in here and do the rename, and the naming should be as descriptive as possible. The first thing that you need to do is adding SM, and this SM represents the static mesh, and it means that this is a static mesh, and we're going to find that better inside Unreal Engine. Of course, a static mesh are things that do not deform. For example, a building definitely is a static mesh because it's not going to be animated, it's not going to be moved and anything. So a static mesh, and then after that add MOD, so that we know that this is a static mesh and it's modular. So the next thing is what type of kit this one is. For example, this is Victorian, so that we know that this belongs to the Victorian kit. Or if your project is Victorian and you know that, you can simply ignore this one. So Victorian, for example, res for residential building, you need to have some sorts of abbreviations in place. So now that we know that this is a residential building, this is a wall, and always after anything you need to add 01, so that later on if you added variations, you can distinguish them from each other. For example, if you create another wall, that this wall is different. For example, having an arc, something like this. So let's do something like this, and now we need to change the name on this one. For example, let's go in here, and now this one needs to be wall 02, so that the naming stays consistent throughout and you can read them. And now we can read that this is a static mesh modular belonging to the Victorian era residential building, and it's a wall 02. And taking the same name, let's go in here, and this one is just like this one, but something different. It's a static mesh modular Victorian residential building wall, and after the wall we need to add window, so that we know that this is a wall that contains a window, and 01. And again, if you wanted to do a variation, you simply duplicate it and make it 02, excuse me, so that, for example, the windows in here are a bit bigger, just like this one, to add a variation. And this one, let's go paste the same name and try to rename it. Static mesh modular Victorian residential, and this one we can call it window 01. Okay, and now we can really just swap it in the place. And let's say that for this one we have another static mesh window. We duplicate this, and in here just set it to 8.2 and place it in here just to make it really the size that we want it to be. Make it bigger so that it covers the whole window frame, and it's done. You see, we have now a good and solid naming convention happening in here. But the thing is that you should never change these naming conventions. You should have never changed the pivot. You should have never changed the material. And you should have never changed the proportions and the grid size of the meshes. So let's go back a couple of steps. And in here, let's say that we make this one bigger by some mistake. So if we export it and go in Unreal Engine, and when we try to re-import this, we're going to get some problems. So you see, now the mesh is bigger, the consistency is broken, the texture is not tiling anymore, and a lot of problems. So you need to have always the pivot, the grid size, naming convention, and transformation. And this transformation means the scale, rotation, and the location of the mesh. You should always place it in the center of the world, just using that bat X, and you should have never messed with the rotation. And we did the scale, and now let's do a rotation. For example, if we do a rotation and export it again, let's go to Unreal Engine and re-import this. You see now it has been rotated very weirdly, and it has done a lot of inconsistency in here. So after this, of course, I forgot something, and that is the UVs. You should not change the UVs as well. Of course, we have demoed the UVs on how we can change the UV. Let me go in here, and this is the UV. If you try to rescale the UV, you're going to get different texture resolution in here and in here, causing the tiling to be lost. So always when deciding on the pivot, grid size, naming convention, transformation, and the UVs as well, you want never to change them, because you're going to have a lot of problems. So this is the end of the introduction chapter. We talked about modularity in theory, and in the next one, we're going to do the practice. We're going to go through the references and find something that suits and start to build them. Of course, until now, we have covered the the step 1, which is the planning and the blockout, and didn't cover the AAA prop creation. And we leave this one for the next chapters. And really, there's no point in going and refine this to make a huge environment out of this, because it's going to be a lot of wasted time. So we have learned about the theory, and in the next one, we are going to create a real scene. We first do the blockout, first do the planning, then blockout, and then I start to flesh out the scene using different kits. Okay? Take your time and learn the theory, because we're going to do practice. Okay? Congratulations on finishing the first chapter. See you in the next one.